Exercise 19. Methanol, in a give me the formula so I don't have to memorize what methanol is, also called methyl alcohol, is the simplest alcohol. It is used as a fuel in race cars and is a potential replacement for gasoline. I don't care. Methanol can be manufactured, meaning produced, meaning methanol is a product, by combining gaseous carbon monoxide, so reactant, and hydrogen, reactant. Fair enough? So we're going to combine CO and H2, and we're going to make this methanol. Next up, let's balance this equation. One carbon on each side, that looks like it's good. Oxygen, one on this side, one on this side. Hydrogen, 2 on this side, 1, 2, 3, 4 on this side, so I'll have to double this. And we're balanced. So our mole-mole ratios are a 1 to a 2 to a 1. Let's write in our molar masses. So if you need to pause to do some calculator work to double check that I'm doing this correctly, feel free. All right. Now let's read the rest of the question. Suppose that 68.5 kilograms of the carbon monoxide is reacted with 8.60 kilograms of the hydrogen. So that's, again, I'm going to put this into grams because I don't like working in kilograms personally. So that'd be 68,500 grams. And that would end up being 8,600 grams. Right? Okay. So let's convert both of these into moles so we can play the what if game. So calculator booted off again. It's getting lazy here. So I have 68,500 grams of CO, which has a molar mass of 28.01. And so I have, let's see, what am I going to call that? 2,446. 2,446 moles of that stuff. And I have I have 4,250, yeah, I'll say 7 moles of that stuff. So let's play the what if game. What if all 2,446 moles of the carbon monoxide reacted? How much of this stuff would I need? Well, I need twice as much. I need twice as much. So multiply that by 2. I would need 4,892. Do I have that much? No, I do not. Right? I do not have enough of this stuff, of hydrogen, for this to be the limiting reactant. So that means that this is going to have to be the limiting reactant. So limits so how much of this stuff so this is going to react all the way. So if this does react all the way, again, we're playing the what if game, how much carbon monoxide will I need to react with this much? I'm going to need half as much. So let's go 4,257 divided by 2. I'm going to call that 2,129. Alright, so I'm not going to react this much. I'm going to react that much. That's how much is actually going to react. Alright, so what's my question here? Calculate the theoretical yield of methanol. Well, let's see. So these react at a 1-to-1 ratio. So if I have 2,129 moles of carbon monoxide reacting, I'm going to produce 2,129 moles of methanol. So the question is, how many grams of methanol is this? Well, look at that. I already have the molar mass. So 2,129 multiplied by the molar mass, I end up with a pretty large number. Let's see. Let's see. What do I do here? Let's call that 35, I guess. So I'm going to produce this much, right? So calculate the theoretical yield of methanol. So my theoretical yield methanol, and this much methanol theoretically produced. All right. There's one of my answers. What's the other one? If this much methanol is actually produced, right? So that means that it's the actual yield. If this much methanol is actually produced, what is the percent yield of methanol? Well, remember, it's actual over theoretical. So I already have theoretical. The actual is, let's see, that's going to be moved over 4 times. 1, 2, 3, 4. So 2 more zeros after that. So that'd be 35,700 grams. Now you can see that it's going to be around half, right? Because that numerator is about half the size of that denominator. Not quite, but pretty close to half. So that is going to be, let's actually double check here. 35 divided by my answer. And I get 52. Actually, let's not forget, I gotta multiply by 100%, right? Because I made that point earlier. So let's multiply by 100. So my answer, notice that we've been using 3 significant figures here, so I'm going to use 3 significant figures in my last answer. It's going to be 52.3%. Are we good with that? 52.3%. Does that jive with my answers? Let's see. So I reported this value in standard notation. This is that value in scientific notation using the 3 significant figures that I should be using, right? So I would have gotten in trouble there on the actual exam. So I really should record this like that. There we go. Now I'm getting full credit. Alright guys, that is the end of Chapter 3.